In this lab, we are going to predict the motion from a falling object. We collect data from the motion of the object on this video. We can see the initial position, the final position, and delta t. We can see in the video that there is a change in velocity, so net force is non-zero. So we construct the model with using Newton's second law, and we introduce the data that we obtained from the video. So when we run the simulation, we can see that there is a very close movement like we saw in the video. Here's some data like delta t. That is the same delta t we have here, and there is the position vector that is not the same. We introduce data in a spreadsheet and we obtain this difference in the curve, exactly in the position. It was the same that we analyzed before, and this difference comes from the air resistance. So we build a model. We include the drag force, and when we run the simulation and obtain the data and include it in a spreadsheet, we obtain this result, and we can see that it is pretty similar with some difference here in position. Maybe that difference comes on the way that we put the mass center in the model. Maybe we have some problems in that thing, and maybe this difference comes from that. But the exercise here is about to model the drag force with in a way that we have proportional magnitude, that is the square velocity, and we realize that when we put a constant, we need to put a very low. We put a very low value. When we run the model, we find that we can obtain the final position that we wish, even if we make this value smaller as we can. We'll never get close to 1.3536. that is the value that we need. So when we put this data in a spreadsheet, we obtain a pretty similar result that we saw in the first model when we used no drag. So as we see here, maybe this is a problem that comes from the nature of the equation that we put on our code. If we want to predict the final velocity, all we need to do is to write here paper.vel velocity, and in the final results, when we run the simulation, we can obtain here the delta t, the position, and the final velocity. This data we have here comes from when we run simulation with our vector of velocity equal to 0. But let's see what happened with the final velocity when we change the initial velocity on our model. So we're going to see if there is difference in velocity and position. So we can see here that there is a difference in the final velocity and the final position. So we're still changing this data. I think we're going to obtain pretty different results than we saw already.